Another specific example is a cube root. And I've given an example of a cube root problem here. This is the cube root of a. So when you look at the cube root of a, again, it's good to think about the definitions. The index here, the number out in front is 3. The radicand, the number underneath, is a. And what does the cube root ask us to do? Find the number b such that b to the third power is equal to a. So now that we know that, we're ready to then continue on with our example 1 and check out part C. So let's find the cube root of 8. Cube root of 8 then is asking us to find a number b such that b to the third is equal to our radicand of 8. Well, 2 times itself 3 times is going to give us 8. So the cube root of 8 is going to be the number 2. Now let's go ahead and check out part D. For part D then, I'm going to do the cube root of -8. Now there's something to note at this point. If you looked at what I had written down for the square root, my statement was find the positive number b such that b squared is equal to a. But you're going to notice here I didn't write the word positive, because in fact cube roots have absolutely no problem with negative radicands. So as you look at this particular problem, the cube root of -8, we can find a cube root when there's a negative under the radical. So once again the question is, what number to the third power would give us a -8? And if you think about that for a bit, we're going to have this 2 again, but it's going to have to be negative, so that you take -2 times -2 times -2, and you get the -8 as the answer. Well, what would happen then if instead of having the negative under the radical, I had the negative on the outside? Well, just like we were seeing a moment ago, negative on the outside then means we first find the cube root of 8, and then the negative on the outside says change the sign of that answer. So we already saw that the cube root of 8 is +2. Change the sign of that answer, and the answer is going to be -2.